Brisbane, and I'm the VP of Engineering at Nozzle. And I'm going to speak about some of the challenges of working with third-party data, specifically the Amazon's ads data. So quick mention about our tech stack. We run on Google Cloud Platform, so we take advantage of their managed services, Cloud Run, Cloud Functions, managed SQL, we're using Postgres, and then the code we write in Python and Vue.js for front end. So Amazon, businesses sell their products on Amazon. We all know this, but Amazon has a rich advertising platform built into it. So when you're looking at your search results within Amazon, when you look to buy something, you'll see inline listings. So it'll say like sponsored products underneath one of the listings. There might be a branded banner at the top. So that's all that businesses use to be able to promote their products and get better sales. And Amazon produces a lot of data off the back of that, on top of the sales side of data as well. So what Nozzle does is takes both sides of that data, combines it, and tries to understand how the business is performing on Amazon, but also try to look at for insights to improve the business, to optimize what they're doing. And that might be to look at, are two different products when bundled together sell better than individually? The keywords that you're using to display your ads, are you bidding too much on them? Are you not bidding enough on them? Those kind of things. So we pull all that data together to try to provide those insights to help businesses on Amazon. Those businesses, the sellers, they have accounts across different regions around the world. So loosely, it's a bit more complicated than this, but loosely it's broken between North America, Europe, and Far East. Within Europe, you have the different marketplaces. So Amazon.co.uk, .de, .it. In America, it's .com. You got Mexico and Brazil. And so sellers will have accounts per region, and then those accounts will cover the marketplaces within each region. As far as the reporting is concerned, I'm going to focus on the ad side, as I said. The reporting is done per marketplace and per advertising product. So Amazon has different advertising products. So as I mentioned, you've got the inline kind of sponsored results. Then you've got branded stuff. They've got display video and some other bits. So it's all broken down per marketplace by the advertising product. There's a selection of some of the products that they have. So for instance, with sponsored products, the reporting that you can get from Amazon is broken down further into these entities within each product. So you have an advertising campaign, and that contains ad groups and keywords and the product ad, which is the thing that gets displayed. And so the reporting is quite granular. So you have a reporting for each of these individual entities. So how much data do we have to pull, and where is the complexity? As I said, the reporting is per marketplace. The other thing about the reporting and per entity, so to get a picture of sponsored products and how your advertising works, you need each one of those entity reports. The other thing about Amazon's data is it's cumulative. So you don't get event level data, you get a summary of a particular entity's activity over a particular amount of time. What that means is that you can't just say, can I have the data from the 1st till the 15th and then get every day within that report. You've actually got to ask for the report for that day. And then if you want the next day, the 2nd and the 3rd and the 4th, you've got to ask for each one of those days. So that very, very quickly starts to add up into a lot of requests that you have to make for reports. So for sponsored products, there's about 8 different entities we ask reports for a given marketplace. And if we're onboarding, so when we first sign up a seller into Nozzle, we try to grab some history so that we can start reporting immediately. Amazon only provides 60 days worth of data, so we're asking for the last 60 days. So it's 60 days multiplied by the number of entity reports that you need over that period. So it's at least 480 reports requests per marketplace for an onboarding. And so you've got all these onboardings for all of these sellers. We started very simple. The first couple of customers we had, just start with cron. It's straightforward. You've got a couple of scripts. The scripts know how to pull down the data, so you just stick it in cron and that works. It's not very scalable though, obviously. So we moved to using Airflow, which allows you to kind of create DAGs and manage this process flow of what data, what reports do we need for what customer, and then where do we need to get it from, and handling all that stuff. We ended up running into quite a few problems with Airflow. We had issues with the actual install and the documentation. So we were using Cloud Scheduler on Google. The version on there, we had some issues with the current version that we were using. Upgrading was quite difficult. Documentation was lacking quite badly. We had issues with scaling the nodes as well. We looked at migrating over to scalable workers on Kubernetes, but that was very time consuming. So at the end of it, we ended up ditching all of that stuff, and we ended up moving to a serverless version of that, which essentially is PubSub plus Cloud Functions and Cloud Run, and essentially have a queuing solution where you have a queue of events that go on, get a bunch of events, and then you have these workers which then consume that queue and then make the requests themselves. So the actual scheduling and handling all these requests, how does that work? Well, the first thing to understand is that once we've onboarded a seller, and they want to regularly get this data within Nozzle, we have to schedule the fetching of the requests every day. So we're only looking at every day we schedule the previous day's data. But there's an SLA on the events that turn up into those reports. So 99% of events will turn up within about 3 hours. And so if you're looking to schedule data for yesterday, what you need to ensure is that you delay that schedule for 3 hours, so that to make sure that you've got all of those events, they've turned up for all of yesterday, and then you can start scheduling. But midnight is relative. So midnight for who? Midnight for the UK, midnight for the US, it's very different. So you have to schedule those based on the time zone that marketplace is in. So now you're starting to have lots of different schedules for the different marketplaces for the sellers that you're supporting. On top of that, you have that last 1% doesn't turn up in 3 hours. It can turn up whenever it decides it wants to turn up. And so you might miss, it's not a complete picture. You don't have accurate numbers. You can't guarantee accurate numbers even if you delay by 3 hours. The other bit as well is Amazon can restate data, which means that it could have recorded 2 clicks on yesterday, but actually one of those clicks was a false click, and so it needs to update the data to say that there was only 1 click. And this happens quite a lot. The restatement can happen more than 72 hours, but usually most of them happen within 72 hours, so that's what we deal with. As far as fetching the data is concerned, I mentioned, we have a bunch of workers that consume off a queue and make all these requests. Now, with lots of sellers, you can be making thousands of requests across all of these different advertising products. And so you have to deal with throttling issues from Amazon. Amazon's throttling isn't documented really at all. They recommend exponential backoff. But their throttling kind of is more aggressive depending on how many people are actually hitting the API and what time of day it is and those kind of things. So you need to be able to handle those. So you can't just spread out your consumers and say, oh, I'm going to have 3,000 consumers and they're going to consume off the queue and we're just going to hammer Amazon. You're going to get throttled really heavily by that. And if each consumer isn't communicating with any of the other consumers to say, oh, I've been throttled, and then everyone else knows that, you're still going to keep throttling with all these other consumers until all of the consumers end up with 49 responses to say that it's too many. So we've limited the number of consumers we have just to avoid that problem, and then also within our queuing system, we've had to take into account throttling, and because it's not really documented the way that we throttle, we're kind of learning as we go and try to adapt better to Amazon. There's token expiry as well. So to make a request, you request the token. That token lasts for an hour. We've had the case where we've been throttled so heavily that the tokens expire in the queue. So now what we end up doing is getting the token on demand. So when the worker picks up the message to say, I need to make a request for this report, then it goes to an internal token service to fetch that a token that can be used. And then I'll quickly talk about processing the data as well. That's been a lot of fun challenges there. One of the issues we came into recently, which was very large reports. Most reports are you can just process them really easily in memory. It's not a big deal. But we've come across reports where the small size is the report size is quite small when compressed, but when you decompress it, it can be over 2 gig in size. On a cloud function, which only has half a gig of memory, you're not going to load that into memory. Now you just think, okay, well, let's just stream the file in row by row. Well, you can't do that because it's a JSON object, and not just that, it's a single big object with nested objects within. So you can't just stream line by line. What you could do is maybe top and tail the file, strip off the container for those arrays, and then go in line by line, pull those out, and then produce JSON objects like so. You can't do that either because there's no guarantee that those items in the array are actually new line delimited, which means you can have a long just a single line essentially of JSON. So what we've ended up having to do is to use a token streamer to parse through, build up a JSON object, process that, and then continue through. And so that's the way that we've had to deal with large files that way. Yeah, I mean, there's tons of things I could go into, but I mean, essentially, what we've learned is to assume nothing and expect everything. We've been surprised a lot by the data and what's documented and what isn't documented. Documentation can go out of date really easily, especially if it's not code documentation about using an API. It's actually about the data itself, so that can be tricky. But also, you might not be the intended audience. A lot of the APIs that Amazon provide were developed in a particular context, but actually the way that certainly we're using, like the ads APIs, it wasn't designed that way. So we're having to adapt ourselves to those challenges and those kind of things. So I hope that was interesting, and thanks everyone for listening.
Thanks, Allan. One of the things I find, fascinating, which I think, not a lot of people is aware, and it was both present in, Vinod's presentation and in yours, and we experienced that at Tech3 as well, is this sort of, back and forth when you're building technology, that while trying new things, you don't know what the result ultimately is going to be, whether it's going to scale, whether it's going to work. Like, what's your framework to approach that? Like, when you're making decision about, trying something, evaluating, like how do you do that, and potentially like how do you align sort of like and create this mentality among your engineering team that not everything that you're gonna do is going to work immediately. I'd be curious to listen to that.
Yeah, there's two parts with that. So there's the being able to understand what you're building, understanding the data, understanding how your technology is meant to be used, and then taking small steps, because you can't predict everything. So you start, you have experiments and you try to build proof of concepts and move along like that. There's also the other side as well, and this is something that we have to deal with is the actual product itself. So what are you actually building, and what are you building for your customers? And especially if you're in a young company, you're trying to find product market fit, the product is going to evolve. And so certain technical decisions that you make early on can actually impact you later on. If the product needs to kind of change direction, you may have painted yourself into a corner if in some cases. And so it's quite tricky. So, I mean, we try to build as small as possible, try to test as much as possible, and try not to go too far down as if we're building a mature product already. We already know what a mature product is. We already know all the use cases and build for that, because you just don't know. I mean, even Amazon is already moving some of their APIs and deprecating some of those things. So we'll even need to adapt to using those new APIs. And so some of the assumptions that we've made and some of the things that we've implemented are very much around those APIs, and we then will need to change. So it's about being light and being about being quick and nimble.
Yeah, that's a great answer. And just to dig a bit deeper into that, like, how do you sort of ensure this the same mentality in the team? Because like a lot of tech companies that are early stage, sort of Series A, Series B, like one of the things they're paying attention to when building the team is finding people who are doing well in a territory where you're often not sure. So I'm curious at like how it works at your stage, and what are the efforts you're making with respect to that?
It's just, I mean, constant communication. So constantly talking about what the objectives are, what are we trying to do, the stage we're at, and the goals. So if we're trying to find the correct fit for the product, what we don't want to be doing is necessarily investing a lot of time in building too deeply as if that is going to last forever. So it's about that communication, lots of experimentation, and just trying to keep in mind short-term goals and then medium-term goals as well, and just getting everyone aligned around those things.